Okay, not all functions have inverses. Take, for example, the common function f of x equals x squared. Okay, we know that that's a parabola. It opens up, vertex is the origin. Right? It should have the points -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Now, based on what we know about the graph of inverses, then the inverse function should be a reflection across the line y equals x. It takes something that is opening up like this, and it makes it open to the right. That's what happens when you just switch the x and the y coordinates. Now, instead of having our parabola opening up, our parabola opens to the right. Okay, so on our f of x equals x squared, what is the value of f of 2? It's 4, right? So go over to our inverse, looking at this graph, right? We should have these, all 4 of these, 5 of these points are just flipping the x and the y on these points over here. What is the value of f to the -1 of 4? So go over to x equals 4. Is it 2 or is it -2? Okay, if it's the inverse, it can't be both. It has to, you know, unambiguously point you back to f of 4 equals 2. And because, in fact, you have f of 4 is 2 and f of 4 is -2, then it's not an inverse. It's not. It doesn't take you directly back where you started from. So we're going to be looking for whether or not a function has an inverse is whether or not, you know, it unambiguously gets you back to where you started from. And in this case, for x squared, it doesn't. So on the next slide, we'll see, we have some ways that we check to see whether or not a function has an inverse. Because we know that they don't always. And we don't want to try to find one when it doesn't have one. So before we start, we want to check.